Thanks, Stacy. Okay, today we're going to get our hands dirty. We're going to show you how it works, really. But we're going to have some slides and some questions. So the agenda today is to deploying and implementing the Symbol Superstore cloud solution. So Symbol Superstore is a fake company. You can find some GitHub repository on Google Cloud Platform who is talking about this company. This is a public GitHub repository. This is a big repository with all the source code from the software engineer and also the Terraform blueprints. And you can use it out of the box to just deploy this solution. So we are not deploying this because there is a bunch of services and it costs a little bit. And it takes a lot of time. So this Symbol solution, today we have this agenda. We're going to deep dive on Compute Engine, a little bit of Gkey, because it's a little bit tricky to have 20 minutes to talk about Gkey. And we have some deployment on Cloud Function and Cloud Run. For the data solution, I think we're going to see this part a little bit later on the agenda, on the next section maybe. We're going to take care of networking and security for sure, because it's really important to have network access within your organization and within your project. And I'm going to talk about a little about Terraform, with the major tool to deploy your infrastructure with the code. So Symbol Superstore, we saw that with Stacy, but yes, the e-commerce cloud solution is designed to be running inside a Gkey cluster. The data is held inside Spanner. Spanner is a really great solution within GCP. It costs a lot of money. And generally, the use cases are more related to financial solution, banking solution. This is a relational global availability inside this solution. So do not use it inside with your voucher, because in 20 minutes you don't have any credit on your project. For sure, we need to expose publicly our application running inside this Gkey cluster. So we're going to have to use a load balancer with facing the public. And because this is an e-commerce solution for sure, we need to have some historic sales inside BigQuery to just leverage the capabilities in terms of business analysis inside this big data warehouse. For the transportation management solution, we have PubSub to receive some messaging, some computing solution with Cloud Run function and data flow to just be able to extract, transform, and load the data. The data is loaded inside Bigtable because we are talking about sensor, telemetry in terms of data ingesting. And Bigtable is a good solution to have a nice throughput in terms of writing the data inside the data storage solution. So for the exam, Bigtable, IoT, telemetry, sensor, those kind of data are generally stored inside Bigtable. Network, VPC. I don't know why there is a regional. You know that. We already talked about that. The network VPC is global. This is a subnet with regional. For the supply chain, we're going to use a Compute Engine, Cloud SQL, maybe PostgreSQL or MySQL solution with Manage. And for sure, we need to be private inside our GCP project. So we are also using networking for Compute Engine and Cloud SQL. Quick design, user, global load balancer with routing traffic to the container who are running inside Gkey cluster. Those microservices, finally, are read and writing the data inside the Spanner global databases. And they're also writing the historic sales data inside BigQuery. The transportation management, so basically we have a fleet of vehicles with a bunch of IoT sensors who are pushing their telemetry or all the metrics related to their behavior to cloud pub sub. And we have a cloud function with trigger on each messages with a kind of guardrail to just trigger the transform processing inside data flow. And data flow is the solution, a managed solution, to write and transform the data inside the big table NoSQL data store. For the supply chain, user and client are reaching the application through a regional load balancer. And behind this regional load balancer, we have MIG for managed instance groups. So basically, this is a bunch of Google Compute Engine that are baked with the same templates and the same application inside their operating system. And those applications are read writing the Cloud SQL inside the backend store. So PostSQL, for example, or MySQL. So, quick reminder, we can interact with GCP with the Cloud Console, with the command line, and programmatically with the Terraform, for example, infrastructure as code. But this is a world of API. You can just make a post if you have the right access and the right token to just contact the compute.googleapi.com, for example, and push a bunch of attributes inside your request to just create some VM, for example. It's not the good way to manage your infrastructure, but it's possible. I'm going to make quick on the slide. I think we need to just see how it works on the real life. So just to make some example on the real world, we are working here from the, like this. Cool. We are working for Davidson Group. This is the name of the company that I'm working with. So basically, we have an organization with Davidson Group, and inside our organization, we have a bunch of folders. We have this folder with some internal folders. This is my folder here. This is my name, Benjamin Coutelier. At the folder level, I own this folder and all the resources that are under this folder. And under this folder, basically, I have 3 projects. Okay? I can see here the charges for each project. And this is not a classic behavior in terms of managing folders in a company, finally. But yes, this is the way that we are managing it here, because everyone in our company needs to have his own folder to deploy his own project, and just be able at this folder level to manage their own resource. Okay? But you can think about something totally different. I work for a retail company with worldwide. And for example, the first level of folder, because the company is worldwide, we have a LATAM folder, an EME folder, what other location I have? I don't remember. A bunch of folders, yes, true, Singapore, APAC. And under this folder, we have some business unit and patati and patata. Yeah.
Just to answer the question, nested folders, 10 levels.
10 levels.
25 was way too generous, it's 10.
Cool. That's a lot of folder. Cool. So let's deploy a compute engine, a simple website inside a compute engine. This is the first product and resource that you are playing with when you are just doing some playground inside GCP. This is the basic one. So compute engine is pretty straightforward. I'm not going to just deep dive for each parameters and each attribute, sorry. This is not possible, but we need to deploy a simple VM. So I'm going to choose the region Montreal. I'm going to give it a name. I'm going to stand with the default machine type, E2 machine type, perfect. I'm going to stand with the default operating system with Debian. I'm just want to see you that we can change the type of disk. Each type of disk have different purpose, different type of performance, IOPS, bandwidth, throughput. I'm gonna just spend a lot of money for my company. I'm gonna choose the SSD one. No container inside my VM. This is so much tricky. I'm not gonna use the backup solution. I don't want to use any replication, synchronous or asynchronous. This is a simple static website. Here, important part, I'm gonna choose the network. We already talked about networking, especially the shared VPC networking. Remember, we have a dedicated project with a dedicated network engineer who are managing this shared VPC with in other project. We're gonna see that a little bit later, but okay, I can choose the network and I'm gonna choose this one, standard 02. Cool. This is not good, but I'm going to give my machine a public IP. And this is not good. We are not exposing publicly each type of machine that we are deploying inside GCP. This is not a best practice in terms of security, okay? Because some scrappers can reach my compute engine, and maybe there is some firewall rules that are a little bit more privileged. We can SSH maybe onto this machine or stuff like that, but it's a demo. No worries about that. I'm gonna stand with the external IP addresses. There is a bunch of parameters that I can switch on and off. For the exam, you can have some question about this little agent, the ops agent. If you don't tick this option, you don't have the agent installed inside your compute engine. And this agent just send all the metric and all the logs from your compute engine to the Cloud Operations Suite and Log Explorer inside GCP. I'm a bad guy, I'm not gonna install it. Here, this is very important. We have to choose the service account that we are giving to our compute engine. If my compute engine needs to have access to a bucket, for example, I need to create a service account dedicated for this compute engine, give him the role object viewer, for example, at the bucket level, to just be able to authenticate himself with the EM googleapi.com. This is a little bit tricky, this part, the service account, but we're going to play with that a little bit later and have some example with the behavior.
So you mean from the VM I can access object storage, for example? If I have a service account?
If I create a service account and if I give him the right EM role and permission on this bucket, yes. And for example, if this virtual machine have a middleware who need to connect to a Cloud SQL instance, the service account need a role with Cloud SQL instance user. It does not mean that it can reach your database inside Cloud SQL, who have also a user and maybe a password to just be able to select and query the database, but just to be able to connect with Cloud SQL. Okay? Here, this is pretty cool. I think you, yes, I know that on AWS you have the same thing, but we can just here put a script which is going to be deployed on the startup of the machine. So I have a little script here, just a little. No, this is a simple one. It's going to just install Apache and just create a static file, okay? And restart Apache. Okay, this is a big HTML file, but
A Bitcoin miner.
cool. And I just need to check here, and I'm going to explain you what I'm going to do. I'm going to pass on the network interface of my machine some tags, network tags. Inside GCP, we can create some security rules, firewall rules based on tag. It's going to be later, but I'm going to just deep dive into this part to just, in quick word, based on this tag, I can reach my VM on SSH, and I'm exposing HTTP protocol. Okay? IAP stands for Identity Aware Proxy, with a managed bastion from GCP. Okay? So basically what does it mean? Say, if I don't have any public IP and just private IP, if I make the firewall rules dedicated to EAP, I can, through this bastion managed by Google, and if I have the right EAM role, connect in SSH onto this machine. Okay?
Just be careful the name of machine. I think we called it website, something like that.
Wow. Thank you. Here, we can see the cost, but the funny part is that I can generate the command line with JCloud. So basically, if I take this command line and I put it inside my CLI, it will deploy the same machine than if I click on the create button. Yes?
We don't need to allow HTTP traffic in the networking window.
Ah, good question. You saw that. Oh no. Oh no. Oh no. Good question. I'm going to see you there. I cannot do that because the firewall setup is not available for template configures for use shared subnet. Basically, if I'm not using shared VPC, it means that the VPC is inside my project and I can manage it with the good EAM rules. And if I tick allow HTTP and allow HTTPS or whatever, it's going to create behind the scene the firewall rules. That's not the purpose of shared VPC. Remember, shared VPC is managed by a dedicated team. I cannot manage the firewall stuff, finally. If I am a consumer of a shared VPC, I cannot do that. Good question. Okay. So, web server.
Is it possible to create an image of this configuration instead of, you just show us a script and we can copy and put it in share or CLI and
Yep.
create this image. Instead of copying and paste the script, is it possible to create an image of the same configuration and once we want to deploy a similar one, we just put it in the GCP.
No, I'm going to show you 2 or 3 things that you need to change to be able to just do the same thing as me.
I mean, I think the question, sorry to cut you off.
No, go.
I think the question is like instead of installing Apache, should I just get an image that has Apache in it, so I just deploy it? So it falls back to like I mentioned, like MIGs, like Managed Instance Group. Like a Managed Instance Group requires a template. That template could be your Apache server, pre-installed within the image, and you just take that image and you're just like, yeah, I need 22 of those. Let's go, and it's gonna deploy it without problem. But when you deal with images, the question always versus scripts is what am I deploying? If you're deploying Apache with a bunch of config that takes a lot of time, might be interesting to bake it in because it's gonna speed up like process time. Because right now, if for some reason we hit the timeout when we do our apt-get to get Apache, then until it's done, our VM is not starting. We're just waiting. Waiting. That's part of the template versus script kind of decision.
And can I know the surface name or tool name in GCP for handling the images? So So for example, I have to open the surface, then it will handle the images that I.
Yeah.
Those templates,
Yes.
we're going to see that in a few moments.
Or,
Because I'm doing it manually, but this is not the normal life. Just to show you some example, after that I'm going to apply a big script to deploy a bunch of stuff with the best practice and instance template as Stacy told us. Because instance template, we can use it inside a managed instance group and just leverage the capabilities of auto-scaling behind the scene. Okay? So, command line, yes, we can post, but no. And we have the Terraform code generation, which is pretty cool. Because if you want to just discover Terraform, for example, this is a good way to start with. I'm going to create the VM.
It is possible to get the Terraform code after the deployment starts.
Yes, this is on a public GitHub repo. You will have the code source for to just.
No, you created a machine.
Yeah. Oh, sorry.
You create a machine and then you want to just.
Yeah, inside your starter script, we can think about a lot of stuff. We can git clone a repository. Just template is for versioning finally your operating system plus your application. It's a little bit old school, but yes, you can do whatever you want.
I think, sorry.
No, go.
I think the ask, like, let's say I've deployed like 22 VMs, a GKE cluster, I created permission. Can I get the Terraform code that would actually recreate what I've click ops? There's a gcloud command that reverse Terraform what you did.
Yeah.
But it's not perfect.
No.
But it gives you an idea. Like there's like everything that you've set, like VM name, stuff like that. Usually it's a variable. You know, and now like it's set hard, so you have to change the code.
Yeah.
So, but I mean, like if you wanted to see what it looks like to spin a VM in Terraform, the Terraform block, there is a gcloud command that does like reverse Terraform. I think it's still not GA, and it hasn't been GA in 2 years anyway, but it exists.
It is not a good way from doing it.
It's not the best way to do it. But sometimes, like, if you're hitting a wall when you're writing your own code, either you can ask, like, of course, you can ask Claude or Gemini or whatever, then you'll get the answer. But before those, which feels like ages ago, you say, hey, what am I missing? Doing that reverse thing was actually not a bad idea. So, oh, that's the parameter I'm missing, or the name that it doesn't like.
So once the VM is running, I think this is the demo effect. But normally I can reach my website. If the script went well, cool. I have this Symbol Superstore just in one VM. This is cool, but this is definitely not the best practice in terms of deploying a secure and robust infrastructure. So here I am inside my VS Code, and I'm going to show you how we can do that in a more professional way. So I'm creating a Google Compute instance template here. This instance has some information that we just discover inside the web console. The type of disk, the source image, some information about the network interface. And we have a startup script with the same that I use for my deployment. So this is the template. I'm going to deploy also a regional instance group manager with a set of VM based on this template. And I'm going to set some information about the behavior of my managed group. So I want to have a minimum instance. Where are the minimum instance? Minimum replica, max replica. These are some variables. So I set it to 2 to have 2 minimum instance and a max of 6 because it's compute engine and it's costing a little bit of money. Inside these autoscaler resources, I'm telling GCP that I want to just add more compute engine if I'm reaching the autoscaler target CPU at 16%. Okay? So if I do a load test inside this instance group, each time I'm using more than 16% CPU, there is one other compute engine who is triggered inside my managed instance group. This is a replication of the behavior of Kubernetes engine. I don't know if you are familiar with Kubernetes engine, but this is the same behavior. So basically, here I'm using Terraform to deploy the big infrastructure. So I'm not going to deep dive inside Terraform. It's just to show you that doing one machine inside the web console is taking me 10 minutes, plus 10 minutes because I just go back without creating. And finally, here, I'm going to create a template. I'm going to create and activating some Google APIs needed for this solution. I'm going to create an instance group manager. I'm going to create a health check because inside the instance group, for sure, if I have an autoscaler, the autoscaler needs to be able to reach the compute instance behind to just be able, if I can, just deliver the traffic to this machine. Are they healthy or not? So basically, they are reaching the HTTP port / index.html to just know if we have some HTTP code 200. And if it's not the case, it's going to kill the machine and recreate a new one. Okay? Behind that, I'm going to create a regional load balancer and a backend service with pointing and rerouting the traffic to this instance group. So normally, it takes 1 or 2 minutes maximum. And we can see inside the GCP console all the components that I am talking about. I'm going to delete this machine. I'm going to show you the template with already deployed. So I have a template based on a machine type, my OS. I can click here. I can see that I have my script. My starter script is here. I have all the information that I pass inside the web console manually. I think we have an instance group who is beginning to deploy some compute engine. Yes. We have our managed instance group with 2 instances based on this template. So basically here I can see that, okay, I have 2 VM that are deployed inside my instance group. And the VM is being verified. The health check is trying to just reach my Apache server to know if I can deliver the traffic for the end user finally. So is my website, is it working real? And the final and really important component is the load balancer. Don't take in consideration this one. We are deploying this one, the symbol web URL map. So basically, it's not very good actually because the instances are unhealthy. They are in progress in terms of deployment. But yes, we are talking about compute and a virtual machine. It takes a little bit of time. Okay. So 1 minute and 48 seconds to deploy all this infrastructure. And maybe the website is running, or we need to wait a little bit. It's already running. Yeah.
But this time you have to manage the firewall rules, or is it still the same shared VPC?
This is the main. I just put inside my template, I just choose the same network tag that is needed that I put on the web console when I'm creating my machine. So I just add the same network tags, and that's the magical part with network tag. We are not using security and firewall rules based on IP source, destination IP. No, we are just putting some network tags, and the cloud is dynamic. We scale up and down. We can just phone call the network team. Hey, I have more IP. Can you add it into my security rule? No, we cannot manage the cloud and the security, and especially the firewall rules like that. That's why the network tags are pretty cool, because okay, I have a template. I make a firewall rules based on this network tag, and for all my instances, they have this network tag. So dynamically, we have an inheritance to just have the firewall distributed at the network interface level. If I refresh the page, I think here we can see the instance name changing because the traffic is managed via the load balancer, and we are just load balancing the traffic between the two instances inside my managed instance group. Okay? Cool. What time is it? Let's go back to our slide. Terraform destroy. That's the magic of Terraform. This infrastructure up and running 24 hours a day and 7 on 7 days. It costs me a lot of money. With Terraform, I can just make a quick demonstration with my code and just destroy my infrastructure at the end. We are using the pay-per-use model and so on and so on. Let's go back here. So it was compute engine. Basically, we are creating a single machine. We can deploy a simple web server with a public IP. This is not good. Definitely the managed instance group based on the template. The template can be versioned to just use the best practice in terms of software development. CLI, I don't like the CLI. It's really cool to just describe and get some information. To deploy some resources, I don't like it because it's not it's imperative. Terraform is declarative. Okay, we have a state, we declare our Terraform code, we apply it, deploy the resource, and if I run again Terraform apply, it's gonna tell me, no, I don't have to deploy something new because you already have deployed those resources. This is okay. So Gcloud is cool to just not create, from my point of view, but just to describe, get, and stuff like that. Okay? If I run this command 20 times, the first it will work. The second time it's not working because the instance is already existing. Okay?
I was saying, like, even though, like, not a fan either of using Gcloud, but let's say for the exam itself, like the structure of the way the syntax.
It's very
of Gcloud,
important.
like Gcloud service, you want to create like a database, so it's I want an SQL instance to create. It's not create instance, it's instance create. Like the order, you need to know that.
Exact.
It's important, and they will try to trick you, like reversing stuff around. Whereas, like when you read it, it makes sense, but like, nah, that's not it. So, but there's always like one or two like this. Is it like dash region or dash dash? Like one or two. It's always on something. But for the exam, on a day-to-day job, like you can do it like differently.
Yeah.
But for the exam, just like
You need to learn about. It's very important to install the SDK. So the Gcloud command, and we can use it for sure to deploy also our cloud function, cloud run function. Basically, we do not see that inside this slide, but here with the Gcloud function is deploying a function with transformation magazine MG function using the runtime Python 3.9. And this Cloud Run function will be triggered based on a message operation on this trigger topic with truck data. What does it mean? It means that inside the repository where the command is executed, we have the Python code. Okay? Yes, because that's the magic of serverless and Cloud Run function. We don't have to create a Docker file. We don't have to install Python 3.9 to do some networking stuff. No. Out of the box, you can just play this command if you have your main.py and your requirement.txt inside the folder. It's going to deploy the function. It's going to GCP under the behavior is going to just package your code inside a zip. It's going to build it inside the container and deploy it on the serverless service with Cloud Run function. But this function is working. This command line is working.
This one, it works, but it doesn't do anything.
Is?
It does anything? Like it listens to a topic?
No.
Comes to the topic, it doesn't.
This function is working, but it's just not working. With this command line, I need a Python.
You need the logic itself, right?
I need the logic, exactly. It's not working. But if I develop my logic and I publish a message inside the topic with truck_data, this function will gonna be triggered. Okay, so I don't know if you have read the workbook, but you have some question, quick question. We're going to see it a little bit later. And yes, we need 10 minutes? Okay, cool. So deploying and implementing compute engine resources, we already saw that just a few moments ago. So yes, this is cool to just go to the web console, just be able to see all the parameters that we can tweak. But this is cool to play the gcloud command line to create an instance, just to discover the behavior of the gcloud and leverage your skills on using Terraform. It's a good skills to have those days. OS login, I don't show this functionality inside the web console. Basically, OS login is just the way that we can handle the SSH key for all the SSH key that we handle generally manually to just be able to reach and connect to a VM via SSH. Okay, so OS login is handling that for us, and it's based on EAM role. If I am a OS login admin, I can just SSH into a compute instance, and I can some sudo command, for example. I am an admin for this instance, and there is another role who is OS login user. You are just a basic user inside this VM. That's pretty cool because managing all the SSH key and the rotation of those keys is pretty tricky. VM Manager is just a solution to just manage your patch management. We can automate the fact that, this VM, each Saturday at midnight, apt get apt upgrade, or just this package, you can upgrade it, or the stuff related to patch management. So this is a managed solution, which is pretty cool to use if you need to just don't have a security issue inside your VM. Quick question. This one is tricky. I let you read it, but this one is tricky. So basically, Symbol has a data center on premise. They are using MySQL database. They want to migrate this database into GCP. The most timely and economical way to do so. If someone want to answer.
D.
Why?
It's E2 standard, so it's not that expensive. Then you install MySQL server, and then you restore movie. Because Cloud SQL usually is would be more expensive. It's a managed service.
Okay. Any proposal? This one is tricky and it's typically a question that can happen inside an exam when you are trying to have a certification for GCP. Okay, my first choice when I was visiting those slides was, wow, most timely, economical way, MySQL database, migration from on-premise to GCP. Does GCP have a managed service to handle magically MySQL? Yes, Cloud SQL. Why this is not Cloud SQL? It was my first. What? Yes, implemented with user-defined function. That's the reason why this is not Cloud SQL. Cloud SQL is a managed service, so it's doing MySQL, PostgreSQL, MS SQL Server in a global way. If you want to migrate to MySQL, Cloud SQL and managed service, you don't have to have some tricky solution and logical function inside your database. It can work finally. So the tricky part was user-defined function. Definitely not Cloud SQL. After that, configure a compute engine VM with an N2 machine type, install MySQL and restore your data to the new instance was the good question because we want to migrate. We need to restore the data. Makes sense. Yes, for sure. I can create this compute engine with gcloud, but the purpose of the question is to migrate our data. We need to have restore something inside the answer. Okay? So this one was a little bit tricky, I guess, because yes, managed services are cool, but if you have something special inside your existing infrastructure, be able to just think, okay, user-defined function, tricky configuration inside MySQL or stuff like that, maybe it's not the right thing to go to the managed service. And generally, on the exam, and that's the way GCP is wants to use their managed service. They want you to use their managed service. And honestly, I prefer to use their managed service because installing a VM, installing MySQL, okay, infrastructure as a service, I need to patch MySQL, I need to handle the databases, the user, the management, the replication, all the stuff related to YAS. So this one is really a common question that we can have inside an exam. Okay, compute engine, option, machine type. We already saw that with Runesh last time. We have a bunch of different machine types, standard, high memory, high CPU, memory optimized, compute optimized. We can have dedicated core or shared core. Shared core are less expensive for sure. And we can also have some GPU for sure. Those days, it's very important to have NVIDIA on the slide. But yes, we can deploy a VM with a GPU. Don't do that on your personal project. It costs a lot of money. There are no good formula. It depends on your use case, finally. I don't have the right formula. GCP has a bunch of decision tree to just be able to, okay, I need to use those kind of compute machine type for those kind of use case. Same for the disk, persistent disk, SSD, local SSD, RAM disk, with some capabilities. Is this disk can be redundant in terms of replication? Can we do encryption at rest? Can we snapshot just to be able to back up and restore the latest version of disk? Local disk. We cannot boot on local disk, local SSD disk. Sorry. And yes, for sure, we have some use case dedicated for each type of disk, and the local SSD is pretty cool if you need to have high IOPS and low latency. Last question before the lunch break. So the backend of Cymbal Superstore consists of a managed instance group. We need to update the operating system of the instance in an automated way using minimal resources. This one is a classic one. I think since 7, yes. Each time I pass a GCP certification with talking about managed instance group, I have this question. So this one is a little bit tricky. If someone have an idea, you can share it. This one is a little bit tricky. So, yes, managed instance group are based on template. We need to see something like create a new template somewhere, definitely. So we can remove the D solution. Create a new instance template, click update VM, set the update type to opportunistic. If you don't know, you don't know. Opportunistic inside the managed instance group. What does it mean? It means that if I have an NLC instance, it's going to remove it. And if I have a new version of my template, it's going to replace it with the new version. This is the opportunistic way to handle rolling upgrade inside a managed instance group. The proactive way, if I set it to proactive and I update the template version of my managed instance group, it's going to replace it as soon as possible, right now. It's going to just kill a VM, create a new one with the new template, remove the next VM, replace it. This is a classic rolling upgrade. Okay? So abandon each of the instances in the managed instance group, delete the instance template, replace it. Basically, he wants to recreate all your infrastructure. This is not good because we want to do it with an automated way using minimal resource. If I go back to my Terraform code, I can create a new template and just change into my Terraform code the reference to my new template, set my managed instance group autoscaler to proactive, and it will do the rolling upgrade without any perturbation for my end users. So, managed instance group, yes. Deploy identical instance based on the template. We can resize it. This is better when we are using the autoscaler. We are not. You can actually do a managed an instance group without any autoscaler. This is a non-managed instance group, and the managed instance group can be regional or zonal. Okay. Cool. Lunch? Mangiare.